Friends, let us see in this video the specific gravity of different fuels as also calorific value of different fuels. First of all, let us see what is specific gravity. Specific gravity, S, is defined as the density of particular liquid, rho. Rho means density by rho water, density of water. Density of water, we know that it is equal to 1000 kg per meter cube. Substituting, so specific gravity of diesel is equal to 0.85 is equal to density of diesel by density of water, that is equal to 1000. So density of water is equal to 1000 kg per meter cube. So what is the density of diesel? It should be 0.85 into 1000, that is 850 kg per meter cube, right? Similarly, on the same lines, gasoline, that is petrol, is having 0.7. Specific gravity of gasoline is 0.7. So its density should be equal to 700 kg per meter cube. 700 kg per meter cube. Now coming to kerosene, this is mostly used. So gasoline and diesel are used in petrol and diesel engines respectively, that is SI engine, spark ignition, and CI engine, that is compression ignition engines respectively. Coming to the kerosene, its specific gravity is 0.8. So definitely its density must be equal to 800 kg per meter cube. Next, coming to the glycol, right friends? So this is used for some specific purpose. It is used to reduce the freezing point of some lubricating oils. Okay, so it's basically used. So now what is this? The density of glycol, it is 1.125. So definitely its density should be equal to 1125 kg per meter cube. A question may be asked. The order may be given. For example, decreasing order of specific gravity out of the 4 fuels and increasing order of your specific gravity. So definitely decreasing is 1.17125. So glycol greater than diesel greater than kerosene greater than your gasoline, right? So this is the decreasing order of the specific gravity of various fuels. Now coming to the, or it may be given increasing orders. So you have to reverse the order. Next, coming to the calorific value. So what is the calorific value, by the way? It is the amount of heat energy liberated by burning 1 kg of any fuel. So this fuel's calorific value given either based on either the mass basis or volume basis. Normally gaseous fuels, calorific value is specified in terms of kg per meter cube per volume basis, but whereas for solids and liquids the calorific value is specified on mass basis, that is kilojoules per kg. So it is mentioned in kilojoules per kg or megajoules per kg as the case may be for solid and liquid fuels, and it is mentioned as kilojoules per meter cube for gaseous fuels. Let us see the calorific values. There are 2 calorific values, friends. One is the higher calorific value and another one is the lower calorific value. So what is the higher calorific value and what is lower calorific value? Higher calorific value is the heat energy liberated by burning the fuel, unit mass or unit volume of fuel, right? Then after the products of combustion are cooled to the room temperature. So actually some water vapor is formed. So if you condense the products of combustion, this water vapor will give off the heat. So this particular calorific value is known as the higher calorific value. But if the products of combustion are not cooled, okay, that means there will be some heat lost by way of the conversion of conversion to steam, because we know that any fuel any fuel is basically a combination of carbon, hydrogen, oxygen, nitrogen and ash. But oxygen, nitrogen and probably ash, they are not going to contribute to any heating value or your calorific value or energy release. Okay, so only most of the things, some fuels will be having even sulfur also as the content. So normally carbon, hydrogen and sulfur, involving these 3, we have a formula for higher calorific value. And from so what is the lower calorific value? Just now I said it is the heat energy liberated when unit mass or unit volume of a fuel, either it is solid, liquid or gas, is burnt on either mass basis for solid and liquid fuels or volume basis for your gaseous fuels. So it is the heat energy liberated without the products of combustion cooled to the room temperature. So then definitely there will be some heat loss because of the conversion of the water. Because we know that when any fuel combines, let us say assume that a fuel is it is having carbon and hydrogen majorly, right? It is going to react with the oxygen present in the air and it is going to form carbon dioxide and water vapor. So this water vapor will take some of the heat generated by the burning of the fuel. So this is, if this is not recovered, what we get? The heat energy, that is called your lower calorific value. So now let us come to the various fuel calorific values. Diesel and petrol are very important, friends. So diesel is having 42.5 megajoules per kg. So these are all probably liquid and mostly liquid and solid fuels are there, and LPG is, of course, it's a gas, but even then it is your it is mentioned as though it has to be mentioned in per meter cube, but it is mentioned in per mass basis, 55 megajoules per kg. So let us see what are the calorific values for diesel, petrol, coal and LPG. So diesel is having, LPG is having the maximum calorific value, that is 55 megajoules per kg. Coal is having, so let us come to next your petrol. Petrol is having 45 megajoules per kg and diesel is having calorific value of 42.5 megajoules per kg and coal is having a calorific value of 33 megajoules per kg. So the increasing order for starting from lower to higher. So let us say the increasing of the fuel calorific value is coal less than your diesel, less than your petrol, less than your LPG. So this is the, let us say, whatever it is, so you can easily make out. So if whether it is a decreasing order, increasing order, so such type of questions can be asked, friends. Not sometimes directly the questions are asked, well, what is the calorific value of diesel or petrol or coal or LPG, and what is the specific gravity of diesel or petrol, or that means gasoline or glycol or kerosene. So these two values, specific gravity of diesel and gasoline and fuel calorific value of diesel and petrol, are important from our examination point of view for your assistant motor vehicle inspector. But remember, if any question is given to compare the fuel calorific value and your specific gravity of various fuels, a question can be asked something like that. Just now we have discussed, right? Decreasing order of fuel calorific value for diesel, petrol, coal and LPG. If you know these values by figures, so you can easily make out decreasing order and increasing order. So that constant greater than something like that will come, and less than will come, like that. Okay. So similarly, specific gravity, the increasing order or decreasing order of specific gravity can also be asked between the diesel, glycol, gasoline and kerosene. Fuel calorific value for diesel, petrol, coal and LPG, and specific gravity for diesel, petrol, that is gasoline, kerosene and glycol. So not sometimes the questions may not be given directly, but a comparison is made between the different types of fuels. Okay, friends. In the next video, let us see. So let us coming to the fuel calorific value. Any fuel will have mostly carbon, hydrogen and sulfur. Mostly, assuming that it is having only 3 elements, but the presence of sulfur is discouraged, because actually it is going to form sulfur dioxide. Sulfur in the fuel is going to react with oxygen in the air and it is going to form SO2, sulfur dioxide, which if it is left to the exhaust through exhaust pipe and combines with the water vapor present in the atmosphere, it is going to form SO2, that means sulfur dioxide plus H2O. It presents in the atmospheric air, it is going to form sulfuric acid, H2SO4. And if it is combined with rain and coming to earth surface with like acid rains, this is very important, friends. So acid rains are going to destroy the fertility of the soils. So now because of this reason, the presence of sulfur is discouraged, assuming that carbon, hydrogen and sulfur are present in the fuel. So the calorific value of carbon is 3380 kilojoules per kg, and your Hydrogen is 1,44,000 kilojoules per kg and sulfur it is 92,79,270 kilojoules per kg. Okay friends, I think it is 33,800. What is this? The calorific value of carbon. So in the next video, so we have seen in this video fuel calorific values and their comparisons, and specific gravity values and their comparison, and also decreasing order or increasing order of these fuel calorific values and specific gravities, and also we have got some exposure to what is higher calorific value and lower calorific value. In the next video, we are going to meet with yet another important concept from your automobile engineering AMVI point of view for both your APPSC and TSPSC. Let us meet in the next video.